Measuring gas properties. Now that we know that gases have various properties such as volume, pressure, temperature, moles, etc., we need to come up with a systematic way of measuring these properties and familiarize ourselves with how to do it. So let's start with temperature. Temperature, of course, measures the average kinetic energy of the molecules. There are a variety of scales that you can use: Celsius, Fahrenheit, Kelvin. The purpose of this video is not to tell you what the difference between all of these are. That is something we should talk about, but we don't. That's not the purpose right here. So you can use any of those. Just kidding, you really can't use any of those. As it turns out, you always, 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 always use this one. You use Kelvin. You always use Kelvin whenever you're doing any kind of chemistry problem, particularly involving gases. So let's just forget that those others exist and always use Kelvin. So how do you find Kelvin if it's not told to you? Well, the way you find the Kelvin is you follow this formula. You have the Kelvin is equal to the degrees Celsius plus 273. A little crazy there. So that's the formula for Kelvin. The only reason you should know any other formula is because you might need it to get into Kelvin. For example, you might have Fahrenheit, but you can't get Fahrenheit into Kelvin unless you know what it is in Celsius. So you got to know there's a couple other formulas that you're going to need to know. So if the problem gives you Celsius, you can use that to change into Fahrenheit. Not that you would. I don't know why you'd ever want it in Fahrenheit. But that's the formula for Celsius. So if it gave you Fahrenheit, you could use that bottom formula. So these are all just formulas. I just wanted to get them up here and let you copy them down should you ever need them. And I'm rambling on purpose so that you have time to copy those down. Okay, if you didn't get them copied, now pause. Goodbye. So we don't have time to get into it, but Kelvin is called the absolute scale. It tells you it's an actual measure of temperature. There's no such thing as negative Kelvin. Zero means zero. So as we said, temperature measures how fast molecules are moving. So as they slow down and slow down and slow down, their temperature goes down and down and down and down. At some point they stop. And Kelvin is a scale where stopping means zero. You can't go slower than stopped. So there shouldn't be such thing as negative temperature. And that's what the idea of the Kelvin is. So if you double a temperature in Kelvin, then its number doubles. For example, 10 Kelvin, double the temperature. Well, now it's 20 Kelvin. That doesn't work that way on the Celsius scale. On the Celsius scale, like 0 degrees Celsius, if we make it twice as hot, it's not now, still 0 degrees. That mathematically doesn't work. So the other scales are arbitrary scales based on nothings. Well, they're based on something, but they're not based on actual absolute values. So Kelvin is the best scale, works the best. It's not really intuitive because you haven't used it a lot, but it's a good scale for finding relationships. So that's temperature. What about volume? Well, volume, there's not a whole lot there's not a whole lot new to say. We've been using volume all year for conversions. Generally, you can use any volume unit for a gas law problem. You can use gallons or cubic centimeters or milliliters or liters or deciliters or anything. You just got to be consistent, although there are some times when you have to, and generally we try to use the liter. So get used to converting cc's, cubic centimeters, milliliters into liters. That comes up a lot. So let's talk about a short, quick way of doing that in case they ask us to do that. If you have a milliliter, cc, or cubic centimeter and you need to change it to a liter, you can always you can set up your chart, but what you're always going to end up doing is dividing by 1,000, and that means moving the decimal point back 3 places. So if we have 48.0 milliliters and we want to change that into liters, well, let's just go back 3 places, bloop, 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 and we have 0.0480 liters. So that's a quick, easy thing that's going to come up a lot, so you might as well just kind of practice doing that quickly. So that's volume. Measure the number of gas particles. That's easy. We use moles for that. We always use moles for that. So measuring the amount of gas is going to be moles. And pressure. Pressure is what most of this lesson is about. Most of the other things are things we've seen before, although temperature is a little new. Pressure. Pressure is something we haven't really done much with. You probably haven't seen a whole lot about it. It's defined as the force divided by the area. So think about it as a push over a surface area. And so bigger pushes over smaller areas make higher pressures. So the units for that is newtons is the standard SI unit of force, and area's standard SI unit is meters squared. So Newton per meter squared is the standard pressure unit, but we don't use that. We make up a new SI unit, and we call it the Pascal. The Pascal, named after Blaise Pascal. And so 1 Newton per square meter is a Pascal. And a Newton is about what an apple would weigh, and a square meter is approximately the size of your desk. So how much pressure would an apple exert over the area of your desk? Not very much. Pascals are really, really tiny units, so we tend to need to use a lot of them. It's a very, very, very small unit. So we tend to use kilopascals. We count them by the 1,000. So we abbreviate that kPa. So the most common gas unit, the SI unit, is the kilopascal. So, but for historical reasons, there are many, 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 many ways that we measure air pressure. You can measure it in bars or pounds per square inch, psi, millimeters of mercury, inches of mercury, kilopascals. We were talking about atmospheres, torr. There's all sorts of different units that we can measure with. Ooh, and I like to do that because it kind of freaks everyone out. Woo, 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 woo. And so those are all of our different kinds of units. We'll talk more about them later. So we have to memorize some conversion factors. There's lots and lots and lots of conversion factors. But first we have to understand something about STP. STP, really important. 90% of your problems that you do in this chapter will say something about STP, so we need to know what that is. S stands for standard. The big T stands for temperature, and the P stands for pressure. So STP stands for standard, temperature, and pressure. Sitting waiting for you to write those down when I'm in an empty room is kind of weird. Are you done yet? Oh, well, you have to pause. All right, bye-bye. Scientists decided what STP was. They all sat together and they defined their own standard temperature and pressure. They just wanted one number for pressure that they could call standard, one number for temperature they could call standard, and the temperature number that they decided to use was 0 degrees Celsius. So if we ever say standard temperature, that is 0 degrees Celsius, which would be 273 kelvins. So the pressure unit that they chose was 101.325 kilopascals. You're very welcome. And yes, you will memorize that, and no, it won't be hard. You're going to do this, these conversion things enough that those will become very easy for you to remember. So in kilopascals, it's 101.325. In Celsius, the temperature, standard temperature is 0 degrees, 273 for Kelvin. STP. So, about those conversion factors, if you can remember what different standard pressures are using the different units, then they can make useful conversion factors. So what I'm going to do is I'm going to give you a list of all the different kinds of ways we can measure pressure and tell you what standard pressure is in that unit. So, let's go. Standard pressures. Well, we already mentioned in kilopascals it's 101.325. There's this other unit called the atmosphere. ATM is how we abbreviate it. That's the atmosphere. And standard pressure in atmospheres is 1. That's kind of a nice one to use. There's another unit called the torr, for which standard pressure is 760. There's this unit that's called the bar, that's 1.01325. You'll notice that looks kind of familiar. It's kind of the kilopascal one, moved a couple of places. There's a unit called the millimeter of mercury. We'll see why that is when we get to barometers. But that standard is 760. Again, you'll notice that torr and millimeters of mercury are actually exactly the same thing. It's just two ways to say the same thing. So that's actually not two conversion factors you have to memorize. One number, 760, will get you either of those. PSI, pounds per square inch, is what that is. It's 14.7 is the standard pressure. And notice that these are all values that are equal to one another. 14.7 psi is equal to an atmosphere, is equal to 760 millimeters of mercury, is equal to 101.325 kilopascals, etc., etc., etc. And so we can use these as conversion factors. So let's see how we're going to do that. Let's convert 250 millimeters of mercury into kilopascals. Well, how do we do that? Well, it's a conversion, so we're going to make a conversion chart. So I'm going to start by writing what I start with, 250 milliliters of mercury, and put it in a little conversion chart. Next, I want to get rid of millimeters of mercury, so I put that unit on the bottom in the chart. And the unit that I want is kilopascals, so I'm going to put that on the top. And now all I do is simply write in the number that is standard for that unit in each place. For millimeters of mercury, the number was 760. For kilopascals, it was 101.325. So my millimeters of mercury cancel, and I'll be left with kilopascals. All I have to do is take 250 times 101.325 divided by 760, 33 kilopascals. So 250 millimeters of mercury is the same thing as 33 kilopascals. And so that is how you do a pressure conversion. And you can do this for any conversion of any of those units, so long as you have a standard for it.